Now we're going to discuss on the load cell. The load cell is one of important application of strain gauge. The function of the load cell is to measure force or weight. So this transducer is called load cell because it is used to measure the deformation that produced due to the force or weight that apply onto the transducer. There are two types of load cell. The first one is axial force load cell. So the type of load cell is depend on the type of forces applied onto the load cell. This is called axial force load cell due to the axial force is applied to the body. A strain gauge is applied to the body in order to measure the strain due to the deformation happen in the body. Here we consider a rectangular beam which size A multiplied with B and axial force is applied onto the beam. The stress in the beam is given as P equal to AB or P equal to A, where A is equal to A multiplied with B. And then we have a relationship with a strain which is stress equal to Young modulus multiplied with strain. We also know that strain is calculated using change of length over the overall length. And the relationship between strain and the change of resistance is given by this equation. So by relating all the equations here, we get stress is equal to this equation. If we want to relate the change of resistance to the force applied, so we can replace the stress with this equation. Therefore, we get change of resistance is equal to gauge factor divided by EAB multiplied with force. Therefore, we can have a direct relationship between change of resistance and force. The second type of load cell is bending load cell. This is due to the bending load that is applied to the beam. So consider here we have a beam and force P is applied at the end of the beam. So it will produce a bending load by multiplying P with X onto the gauge here. Moment of force at the strain gauge is this equation. Using Coulomb law, we can relate the moment and the stress using moment over I equal to sigma stress over H, where I is the second moment of area and H is the distance from neutral axis. Using the same flow, we can relate force, moment, stress to strain, then to the change of resistance. This can be done by substituting the moment of force into the equation. Therefore, we can get the relationship between stress and force in this equation. The moment of area, I, is calculated using AB cube over 12 and H is B over 2. Replacing all the parameters into the equation here, we get the relationship between stress and force is 6x over AB square. Next is to relate stress and strain. We know that the relationship between stress and strain is from the Young of modulus. Strain is also related to the change of resistance by this equation here. So putting the two equations together, we get the relationship between stress and change of resistance. From the previous equation and also the equation for the strain, now we have two equations that representing stress. The first one is the equation that relate to the force and the second one is the equation that relate to the change of. By equate the two equations, so we can relate the change of resistance to force by the factor of 6GF multiplied with X divided by EAB square. This example will illustrate how the steps in calculating the force or change of resistance depend on the problems. Given in this example is a load cell. This is the design of the load cell. So the strain gauge that used is having a nominal resistance of 120 ohm and used with a bridge, Wheatstone bridge, in order to convert resistance to voltage. This is the design for the strain gauge. So first we need to find the change of resistance. So this is the design for the load cell where we have a column. Okay, so we have two strain gauge here. Only this one is used to measure the strain because this is the strain gauge that's sensitive in the direction due to the load. And this strain gauge here is not measuring any strain because it is in the direction that insensitive to this direction. The function of this strain gauge is as a dummy strain gauge. Later we will discuss on the concept of dummy strain gauge. So in order to calculate the change of resistance due to the force acting on the load cell, given the force that add on to the load cell is 5,000 pounds. So we convert that value to the Newton, which is 20,240 Newton. So first, let's determine the type of load cell here. From the figure here, we can say that this is axial load cell because the force is axially to the strain gauge. So this is axial load cell. Since this is axial, we know that the stress will be equal to P over A or equal to P equal to AB. This is area A. And we relate to the strain, which is multiplied with modulus Young. So therefore, the strain is equal to PAB multiplied with E. So let's calculate all the values here. So given the force acting on to the load cell is 5,000 pounds, so we convert that to the Newton. Then we calculate the cross-sectional area since that is aluminium rod. So area is pi r square. So given area is this value. Therefore, the strain is equal to F over EA. F is 2,240 Newton. Modulus Young is 6.89. And area is this value here. So we get strain is 1.644 multiplied with 10 to the minus 4. So then we relate the strain value to the change of resistance by this equation. So given the gauge factor is 2.13, strain is 1.6 multiplied with 10 to the powers of minus 4 and nominal resistance is 120 ohm. So therefore we get the change of resistance is 0.042 ohm.